in the last class, we have discussed something about the introduction, linked list. Now, let us see a little bit more about linked list, and then we'll move to the further content. So, linked list is a linear data structure. Linked list is a linear data structure, and it has a list of nodes are present in the list. Each node is consisting of two parts. One is data part, and another one is link, which is a pointer which points to the next node. So the first element in the list is called as head, and the next and the last element is called as tail. Okay, always the first element in the list is called as head, and last element is called as tail. And there is no limitation of size as the way in arrays. So you can extend. It can be it can grow or shrink in size during the execution of a program. That means you can add any number of nodes. You can delete any number of nodes. It depends upon your requirement. There is no memory limitations. Memory limitations in the sense, in the array, if you declare array of 10 elements, okay, you are able to hold only 10 elements. You cannot increase the number of elements which you want to be stored more than 10. But here it is not the case. You can add any number of nodes to the list, and you can delete if you want. Okay, so which is also, linked list is also a, what is linked list? Linked list is also a linear data structure. Array is also a linear data structure. Okay, now let us compare the differences. What exactly the difference between array and the linked list? So the size of the array is fixed, because it need to be decided at the time of declaration and all. Okay, so whatever it may be, the number of elements you want to store into that, you can store it according to the size, right? And another important point is array elements need contiguous memory locations to store their values. That means continuous storage locations need to be allocated for array. Memory space should be allocated in a sequential fashion. And inserting an element in an array is a performance-wise expensive, as we have to shift several elements. But suppose if a list consisting of 5 elements, imagine 1, 2, 3, 4, 5. Okay, 5 elements are present in the list. If you want to add 7, a new element 7 after the second one, or after the first one, after the first element in there, what is the elements of the array? 1, 2, 3, 4, 5. You want to add new element into the array after the first position. That means in between 1 and 2, you want to add new element. Okay, for example, 7 you want to add in between 1 and 2. What you are supposed to do? You need to be shift all the elements from the second position to the next. That means the 5th element need to be moved to the next location, and then 4 will be moved to the position of the 5, and 3 will be moved to the position of the 4, and 2 will be moved to the position of the 3, and then you can make an empty space in between 1 and 2. Then only you are able to insert the element into the array. So that is what several shift elements to make a space for the new element, right? So similarly, deleting an element from the list is also a performance-wise expensive operation, because you need to shift all the elements backward to the locations, whereas while inserting, we'll move to the forward direction. So these two are the some of the limitations of the array. And now, how these limitations will be overcome in the linked list is, linked list allows dynamic memory allocation. Dynamic memory allocation means the memory will be allocated during runtime rather than compilation time, right? So you need not mention the what is the use of allocating memory at runtime. You need not mention the size well in advance, because it automatically when you are running your program, whatever it may be the number of elements you are adding, based on that the size is going to be increased. But whereas in the case of arrays, before executing the program, you need to define what will be the size of the array, and you are supposed to enter only the elements according to the size of the array. Right. And another important point is linked list elements do not need contiguous memory locations. Contiguous memory locations. They might be, suppose, for example, imagine a list contains 3 elements like this, A, B, C. Okay. So in this case, the first element is A, second element is B, and third element is C. In the case of array, for example, the address of A is 1000 location. Okay, it is a character, it requires 1 byte of space. So that's why B will be stored in 1002 and C will be stored in 1003 in the case of arrays only. In the case of arrays, the elements need to be stored in contiguous memory locations. Okay, whereas in the linked list, the elements will be stored anywhere in the memory. All of them are linked with the address. In the diagram, if you observe in the current slide, A is there is an arrow mark. There is a indication between linking between A and B with the help of arrow mark. What it indicates is the next part or the address part of the node contains the address of the next node. The address of the next node which is going to be connected. That means A contains the address of B. A contains the address of B and B contains the address of C. That means the address part contains address of C. So in such a way, it is pointing. So wherever the nodes, wherever the elements are stored, okay, all those elements will be linked with the help of this address. So that is the reason all the elements in the linked list may not be stored in a contiguous memory locations. So anywhere you can store, you can link with that address part. So insertion and deletion options operations in the linked list are not performance-wise expensive because there is no such kind of several shifts while inserting or deleting. You need not move all the list of elements to the right or left. You need not do like that. Okay. So whatever it may be, the element which you want to delete, what is the operation? What are the steps that are involved in the deletion? First, you need to find out the element where it is present, whether it is present in the list or not. Okay, first case, if it is present, then you need to check whether it is null or not. Okay, whatever it may be. So whenever if you found the element, automatically you can delete that element. You need not shift elements left to right or right to left while inserting or deleting the element. So it is not a performance-wise expensive one. We'll see all these things. I will execute very soon a simple program how we are going to be create a linked list, what way we can add, and then we will clearly observe the difference between array and what insertion in array and insertion in linked list. Right? Okay. Then in the similar way, deletion also. Only a simple operation is required for deleting an element. We'll illustrate all these things in the upcoming slides. Now, coming to the some of the drawbacks of the linked list. Some of the drawbacks of the linked list. So, random access is not allowed. Suppose if you want to search for a particular element, you need to start from the beginning. That is from head onwards. Okay. So we need to start from the beginning and we'll move one after another. Directly you cannot go to the place. Directly you cannot go to the place, right? And of course, with some additional features that are added to Java right now, we can do that. But in basic structure, if you are talking about, it is not possible. Now, extra memory space for a pointer is required with each element of the list. So, as we have observed while creating a node, there it consists of, every node consists of two parts. One is for holding the data and another one is for holding the address of next element to be connected. Next element to be connected. So here along with the data, we need to maintain another field called address field. So to hold that information in the memory, that is going to be wasted. So not cache friendly. Since array elements are contiguous locations, there is a locality of reference which is not there in the case of linked list. So suppose if an array consisting of 5 elements, an integer array, okay, so each integer element requires 2 bytes. Assume like that there is an integer array, int array of 5. Okay, so what will be the total memory allocated for that array? If it requires integer variable to hold the integer variable, it requires 2 bytes. So in that case, total 5 elements, 5 into 2, 10 bytes of space is enough to hold that. So if you know the starting address of that array, you are able to traverse all other elements which are present in the array. Because suppose if the starting address of that array is 1000, the next element will be stored in at the location 1002. Next element will be stored in the location 1004. Like that, you are able to traverse if you know the starting address of the first element. But it is not same in the case of linked list, because all the elements in the list, all the elements in the linked list may not be at the contiguous location. They may be stored in the different locations. So definitely, if you know the address where the next element is present, then only you are able to move. Otherwise, it is not. So that is the another drawback of linked list when compared with the arrays. Now, see, this is the creation of linked list. I mean a node, not linked list, a node. See, if you observe the subclass in it, class node, it consisting of 2 data members. One is data and another one is node next. Node next. Node next in the sense, again, self-referential data structure. So it references to the same class only. Node next. Next is of type node. What is node? It is a class. Now you can observe the constructor in the class node into D. The definition part consisting of data is equals to D. So whatever the data which you want to assign to the node, directly you can pass. So that will be stored in the data part of the node itself. Okay. And you are supposed to, suppose that is the first node creation. First node creation, suppose if you have entered the data as 1, okay, so node 1 is created with the value of 1, and now the address field. What is the address field of this one is, initially it is by default it was assigned to the null. Okay, when you link this particular node to the some other, automatically the null will be overridden. Okay, so for example, if you create a second node, and you can add a data 2 to the second node. First node is present with the value 1. Second, another node is also be present with the value 2. Okay. Now, if node 1 dot, the name of the first node is node 1. The name of the second node is node 2. Node 1 dot next is equals to node 2. If you write the statement like this, once again all of you observe it. Node 1 dot next is equals to node 2. What it means? The address part of the first node will be filled with the address of node 2. So automatically a link will be established between node 1 and node 2. If you write the statement, after executing the statement, automatically a link will be established between first node and second node. Similarly, as I told you, while creation of the node, the data part will be filled with the data supplied by you, and second part by default it is going to be initialized with null. When you write the statement like this, node 1 dot next is equals to node 2, what happens is node 1's address part will be filled with the address of node 2. So in such a way we will add. So this is the structure for the creation of the node. So what are the basic operations that you can perform on the linked list is, you can create a list, you can traversing the list, like searching for an element in it, inserting an element, and deleting an element, and concatenating to list, and many other operations are also be there. But these are the basic operations which we can perform on the linked list, or simply you can call it as a list collection. So now let us see what is the things that you need to be consider while inserting the element. So for insertion, a record is created holding the new item. First, what we have to do, you need to create a new node which it holds the new item. So the next pointer of the new record is set to link it to the item which is to follow it in the list. That means suppose if it is the first node, then you need not connect right now. Suppose if already a list is there, for that list, if you want to add the element, insertion can be done in three different places. One is at the beginning, and another one is at the end, and third one is anyone in between first and last, any place in between first and last. So these are the three different possibilities where you can insert an element, right? So here the newly created node, you need to be decide whether you want to add it in the first, or whether you want to add it in between first and last, or you want to add it in as a tail node. Tail node means the last node is called as tail node, first node is called as head. So if you want to make the new node as a tail one, what you are supposed to do is the tail dot next is equals to new node. The tail dot next is equals to new node. Before writing the statement, what is the value which is present in the tail dot next? Null, because that is the last node. So you did not link with the any other node. So that's why initially it is filled with the null value. As I told you, while creating of a single node, any node, the first part will be filled with the data supplied by you, and the second part will be initialized with the null value. So as a part of implementing it, the last tail node consisting of null initially. Whenever if you write the statement, like tail dot next is equals to new node, automatically the null part of the tail, previous tail, will be overridden with the address of newly added node. Okay, now you have successfully added your new node at the end of the list. So what is the next part of your new node? Yes, again it is null, right? So in similarly you can insert at the beginning and you can insert it in the middle. We'll see the program for the entire operations, insertion operation. Like there we can add at the beginning. We'll try to add any of the place in between first and last, and we'll also see at the end how to add it at the end. Until then, you should have some idea what way we can add the element into it. Okay, right. Then the next point. Okay. In similar way, deletion. The next pointer of the item immediately preceding the one to be deleted is altered and made to point to the item following. I'll show you diagrammatically how the insertion and deletion are going to be taking place. So now, see, this is the original list A, B, C, and then if I want to add a new element called temp, the name of that new element is new node is called as temp, and I want to add where I want to add in the second position. So current position is A, that is the head, and I want to insert the X in between the elements A and B. That means first node and second node I want to place temporary node, right? So for that, what I have to do is, first thing here you need to observe very important point. First you need to link the temporary node next to the B. The temporary node next to the first, you are supposed to write the statement temp dot next is equals to B, and then you can write A dot next is equals to X. A dot next is equals to temp, right? Once again I'll repeat, temp dot next is equals to B, temp dot next is equals to B, and then you can write the statement current dot next is equals to temp. If you reverse the two statements means if you write the first statement as current dot next is equals to temp, automatically what happens is the previous link between A and B will be disconnected automatically. So if you did like that, what happens is these two elements, these two nodes, that means current node and temporary node are in the list, but what about B and C? They were disconnected from the list. So that is the reason, first whatever it may be the new node which you want to add, the next part of that node need to be linked with the B, and after that you write the statement current dot next is equals to temp, so that automatically it will be added in between A and B. So that is about insertion. And then coming to the deletion. So if you observe the head node, data item, that means node 1, node 2, node 3. So the target node is the node which I want to delete from the list. For that, what I have to do is, so whatever it may be, the first node in the sense next to the head, okay, or you can call it as a second node. So the second node, you can observe the arrow mark. Initially, dotted lines are there. That is the original link already established. Now I want to delete that element. So for that reason, what I have to do is simply I'll connect the second node dot next is equals to the last node. So automatically what happens? The link between the second node and the third node is going to be disconnected. Okay, and automatically that element is going to be deleted. Right? So this is the operation which you can perform on the deletion. Okay. Now, before going to discuss about this different types of lists, we'll see an example program how to create a single linked list. Yeah, so all of you observe this program. Initially, I just try to create a node, class node in as I shown you in the previous slides. Okay, so initially I created two nodes. One is public node head is equals to null, public node tail is equals to null. Initially I was created two nodes which contains the value as null. Head is equal to null in the sense it was initially assigned with null and tail is also be assigned with null. Okay, now I want to add a new node to it. What I have to do is create a new node. So all of you observe this. I will highlight all these things. Okay. No, this is the way you are supposed to create the new node. New node. We are creating object to the this particular one. Okay. New node is equals to new is the access specifier for allocation of memory, dynamic memory allocation, and node data 2. Okay. Now it is okay, I think. Right? Okay. If you have any, are you able to see this? Yeah. Okay. Now, still you are unable to see it? I think now it is visible to you. Any one of you? Okay, done. So this is, once again I'll repeat because you are unable to view my screen. This is the way you can create, this is the class which is used for creating a new node. Here I was created initially two nodes, one is named with head and another one is named with tail. Okay, so these two are created initially with null values. After that, if you want to add new element to the list, what I did is, so this is the way you're supposed to create new node. Okay, so new node is equals to new node of data. If head is equals to null, the list is initially, because initially you have assigned it as a null, so always it is initially null. That's why I'll make the new node as initially the new node as both head and tail. That means two tags are added to the newly created node, first node, right? After that, if you want to suppose okay, that is the case of first element. If you want to create a next element, so in that case, head is not a null value. So that's why it will be moved to the else part, where I can write the code like this: tail dot next is equals to new node. Tail dot, what is tail right now? The first node which we have added. Okay, so tail dot next, that means previous node dot next is equals to current node.